Hello, good afternoon. Welcome back to the joint logistics session. We are here with our next presenters, JD Stanley, and his colleague might join us shortly. He's with um, IoT AI, and go ahead and take it away.
All right, thank you very much. Assume you can see my slides. And if Amanda joins, I'll let her come in too. Thank you very much, Tradewind, for allowing us to participate. We greatly appreciate it, and also for any of the DoD and other members of the industry who are focused on innovation. What we're doing right now is we're focused on who we are. We have the buzziest name in the world for a company, IoT and AI mixed in there. We even have the domain of IoT.ai, so you all have to laugh. I came out of Cisco in 2019 with my co-founder Kevin, who said, "Come help me," because he thought it was on his third gen capability. And an Air Force customer actually said, "Oh, go get this name." I said, "There's no way that's available," but it was, and we were able to capture it, build the company on that, and so forth. My co-founder Kevin was a NASA scientist, Stanford professor, ran the Army telemedicine lab out of Stanford, so very seasoned in that, Smithsonian Award winner. Myself, I was at Cisco for close to 20 years. Actually, I ran PhD AI teams on many different topics, which is unusual for Cisco, and also some of my patents were in the AI space. Amanda should be joining us. She'll be here. She is basically one of our customer experience managers. Has a lot of expertise in kind of domestic security issues, international security issues, and those types of aspects. One thing I wanted to highlight to you is that we at IoT AI have had proven success. So we're pretty relevant to the mission. We're a dual-use company. We work in industrial power plants. We've been used by very large retailers and distribution facilities for exposure health monitoring. And we also have been very successful in very kind of metal-rich, very constrained, degraded conditions on the commercial side for oil and gas and industrial. Additionally, though, for the last 3-year journey, we focused a lot on how we could expand our commercial parts of our business actually into helping the mission. And that includes the following. One is around industrial aspects. There's a lot of that inside of that. You think about shipbuilding, power plants on bases, those types of things we're very good at. But then we actually dived into aircraft maintenance, Air Force maintenance, sustainment, and so forth. So we were on ABMS on Ramp 2. We've done things around other ABMS and agile combat exercises. We've integrated with both ground-based and aerial-based systems. We've integrated with proprietary tools and so forth. And then additionally, what you're going to find is that we have done vertical lift through to Army validation and even Trident Spectre and Coastal Spectre. So we've actually been on destroyers and communicated from offshore to shore. But the most important thing is what we're trying to do is saying, how can we help you solve this mission problem of low cost, low swap, within high interference, degraded, disconnected, intermittent, inadequately connected systems that allow you to actually do things at the edge that are promised for Army Future Command and other aspects, but do it more today and not 2030, 2040, and so forth. Given what the capability is, here is where you're going to find is what we're focused on is this extreme IoT space. Extreme IoT is very similar to kind of battlefield of things, but in the commercial world, there's still lots of places when you walk through a power plant, there's not a lot of good connectivity. There's no AI that's wearable on that person. Communications, collaboration applications are very limited, and that's where a lot of our industrial customers were. Additionally, when you think about IoT, they usually cause you to do a lot of pre-existing infrastructure or deploy a lot of repeaters, those aspects. On the battlefield aspects of that, it requires you tactical radios, put up satellite dishes, basically lighting yourself up in lots of signatures, and then actually having to put in extra servers on vehicles or on boats, those types of things when it comes to the actual computing capacity, and then bringing in other systems. It kind of gets really loaded. And so what we set out to do is to solve these challenges in a wearable component. So cyber threats, EW threats, inadequate connectivity, sensor silos, AI ML at the tactical edge, at the very tactical edge, and I'll give you a little more insight to that. Constrained conditions where there's low power, low ability to actually operate, size, weight, power as a massive constraint, those type of things. And that's where we've been really good at doing. And then the Pico Anywhere Suite is our suite of family of devices, which we'll find is every one of our devices has the same core components. We build the breadboard, we build the software, we actually build the cyber and EW threat detection components, and we put it all together in a way that actually allows you to have a wearable device, a mountable device. And this little graphic gives you at least a sense of that. So we have flown on UAVs. We actually are a winner of StrikeWorks, which I'll tell you a little bit about a Star Trek communicator of the future. We've been on age equipment through to Army vehicles. We have actually instrumented quite a bit out there about how do you connect up these cooperative intelligent systems in a mesh-like ad hoc manner with no dependency in cloud, no dependency on servers, no dependency in tactical radios, no dependency in SATCOM. And that was our mission, to go off and solve that problem. And we've done extremely well. So here's some just far edge use cases. At CyberQuest, we provided an entire squad, both a tactical squad and an EW squad, with full communications, collaborations, no tactical radios, actually operated within metal-rich environments, tunnels, subterranean, and thick forest. And we also did that within contested scenarios. Disaster areas in Puerto Rico. After disaster, we have 200-mile-per-hour antennas providing multiple kilometer communication system, all once again wearable, packable, very small, lightweight, and then also providing cold chain monitoring. So little math models monitoring the temperature of the blood refrigeration units. On ABMS, we're doing things, for example, around aircraft maintenance, repair, rearm, or resupply, where we did this capability in very constrained, contested conditions over dirty, non-trusted environments, and then providing them back. Camp Lejeune, if you know anything about Camp Lejeune in the deep forest, deep wooded areas down in the mountains, there's very little connectivity. We did health monitoring, heat exposure, so local AI operating with local sensors of body temperature, those types of things. And then also we've done things for exposure monitoring and thermoelectric power plants, flow control analysis, communication analysis, threat analysis, even in the critical infrastructure components. This is a public one. We typically do not publish what we do publicly, but the Air Force publicized this. That little round hockey puck size device right now, it was the winner of StrikeWorks version 1. In essence, we pitched the first Star Trek communicator in the world. We thought we would just replace a pager, but then they asked, could you put this into a Star Trek-like badge? And so in our first iteration of this, in less than 5 months, we miniaturized our technology to allow a full communication, hands-free ATAC service, mesh distributed environment, multiple tens of kilometers actually capability with no pre-existing infrastructure and the ability to kind of survive worst case scenarios. So this system has a lot to it. It actually is a wearable communication, collaboration, AI, ML processing, sensor integration system, all into a size of basically a patch that'll be wearable on the uniform. We're in our second generation of that now with Global Strike. We're building it out. And so that capability, once again, does provide hands-free audio in addition to other capabilities of sensor integration and also integrating into any kind of environment to provide not just a 1 unit, but 2 unit up to scaling to 10,000 units with no backhaul, no network, and no other pre-existing infrastructure required. And this gives you a little bit of sense. We've built a modular system. We've built an intelligent software system on top. It is a distributed mesh operating system. So although we build hardware, our entire hardware system is actually physically secure. We then built the virtual firmware on top and the operating system on top. So we're cyber secure. And with SOCOM, we're actually building EW detection and also mitigation techniques as part of a program we're doing with them. And so these devices are about 7 ounces, different form factors, but the same core components are the same. It is a neural network. It allows us to process AI, ML at each node and all at terabits per second, and also process that across the mesh with no clouds, no server, no network dependencies. You don't have to be constrained by a tactical radio or by SATCOM, which have limited bandwidth, inadequate connectivity in these environments. And we're still processing the data at a single node. And then we can actually process the data distributed across all the nodes, once again, without any other dependencies. This entire system can be air gapped in itself as an overlay system or completely hot swap into any other uplink validated and proven. Even on a Navy destroyer, we went bow to stern, and we even escaped the small arms room and also 10 kilometers offshore. Here's some modules and kits we've been working towards. Small operations, as you know, rescue through to, this is fire rescue, emergency rescue, pilot down type of rescue situations, kind of SR operations, point of need. As you know, many things at the point of need where the soldiers really need it, or the Navy and so forth. Like on the ship, there's a lot of manual paperwork still for maintenance sustainment operations. Or when you go ashore, if you need a low signature capability, but you still need the squad together without expensive radios, and you want everyone to have ATAC, for example, it's a different type of use case. We're not here to replace a tactical radio nor replace an edge server. We really are augmenting other systems out there, but we do provide continuous kind of interference resistance capabilities when those other systems go down, and we keep and maintain the local C2 in those situations. So maintenance sustainment is really important in metal-rich environments. You can think about shores and ports, or actually on the ships or aircraft and others. These micro mesh techniques go into sensors. We're a sensor company, so we support all kinds of sea burn sensors through to radiation sensors, health monitoring, exposure sensors. Austere logistics, as we've been doing quite a bit around the combat logistics side, with Agile Combat, with SOCOM and others. Perimeter security is kind of an area we've been expanding to, kind of a pack and go perimeter security, so augmenting existing perimeter security. The good thing is for any base operations or any ship-wide operations or any place that you have the PII issues, we can actually process object detection, our software or other third-party components, as long as it's built for that environment, doing full AI, full ML, full neural network at the point of need with no other dependencies outside of that point of need. And so there's ways that we could actually look at sensitive environments, provide you object detection, alert detection, IR detection, or actually provide more of a constrained environment where you can't stream all the data, whether it be UAV, ground-based camera, do some of the local processing, and then process only what's really important, that last 10%, 9%, 5%, up to the command center. Constrained environments we're doing a lot of work in. We do have a government, so in a CUI environment, non-here, I can highlight to you what we've actually done at Trident Spectre, CyberQuest, Silent Swarm, Coastal Trident, and others in these kind of constrained and contested environments for both comms collaboration, but also the AI processing, communication, sensing aggregation, sensing fusing. The other really good one is point of need training. A lot of real world training environments, non-lab, non-enterprise laptop, VR. VR is a hot topic, but VR doesn't translate down to these constrained edges. So we are mixing some of the AR components, but we provide full communication collaboration within constrained environments like the Camp Lejeune, so that way you can train in real world conditions. When it comes to logistics, we did provide this slide to you only for background to be able to have you engage with us in the future. We actually are pretty good at these constrained, degraded environments. As part of that, there really are two elements when you think about austere logistics, especially across any, what I would say, kind of transfer, transmission, forward deploy, pack and go environment. And so just like what we're doing with Global Strike is we're providing a capability that is handheld and wearable, much smaller than their big crates they have today, for full aircrew alerting anywhere in the world. So it's pack and go, and it doesn't depend on any other system if it doesn't need to, but it will integrate up to 5G and to SATCOM and whatever they want to integrate into. The same thing goes for logistics. In many flight lines or many depots or many ports, connectivity is a problem. But once you get connectivity, then you need apps, things like ATAC. Then once you get connectivity, you get apps, then you got, hey, can I process data locally because I can't get back to the cloud all the time? There's bandwidth constraints. Or I want to integrate sensors at the point of need because I'm doing inspection, whether it be metal degradation, performance inspection. You think eddy currents. You think about the kind of ultrasounds, those types of devices for sustainment and maintenance. That's what we've been doing really good at. We want to track devices. We have location services, both GPS and non-GPS capabilities, once again, without any pre-existing infrastructure deployments. And that really comes into where forward deployed, we do multiple kilometers of all of these IT services. So what we've really done is we've taken the IT stack that has been traditionally in the enterprise side. We've converted that all into these wearable devices or mountable devices, all 7-ounce size, so extremely low swap, extremely low power, 1 watt max on the communication side, 3 watt max on the AI processing side. We know no one in the world that can match us. In addition, we've built the software layer of these intelligent IT SAC services, distributed AI, ML, up to 10,000 nodes. I only know of companies can barely reach dozens of nodes. That was funded by the Army STTR side, so validated and proven across multiple government tests and validations. And that allows us to say, how do you now unlock these edge use cases when you don't have comms, or you don't have a cloud, or you don't have a network? And then when you do have those, great, store and forward, we'll uplink, we'll do burst, we'll do full communication, whatever's available. But then what do you do when it's not available? And that's really what we've been trying to say is the stack of services that are required to do AI ML at the far edge in these constrained environments. How do you unlock those to be more effective for the point of need field worker, logistician, sustainer engineer, or tactical member? And that's what we can talk to you about under CUID, the different use cases we have, the different SIBRs that we're actually under between DTRA, SOCOM, Air Force, and Army, and the other things that we've been doing, even the Navy, like in Coastal Trident and Silent Swarm. And so I will leave you that combat logistics, whether it be for the everyday situation, improving things that you have very limited and constrained environments for those field workers, those logisticians, those places where they just get frustrated, where ATAC's only connected 30% of the time, or that they don't have location services working all the time, or they can't even radio to their depot to get a part. Those kind of limited conditions, we can help in automation of the workflow and digitalization. And then for those other really important mission sides, where you have constrained environments, cost limitations, even low signature requirements, those types of things is where we've been doing quite a bit of work to improve threat detection, threat mitigation, automation, digitalization of the C2 environment, and also the AI ML processing, including at the point of need without dependencies anywhere else. So we thank you for your time today. They have our contact information, and we do look forward to engaging you in the future.
And I do see that Amanda Henninger came on stage. If you'd like to come and use the last 3 minutes to add on to this presentation. You're on mute.
I had some difficulties logging in. So I just want to say hi to everyone and thank you for your time today. We really appreciate being invited to participate on this, and we look forward to discussing future opportunities for collaboration. So if you have any questions, feel free to reach out to either one of us, and thank you again.
Well, so Amanda, you, since we have a few minutes, you've met some folks like last night on some of the Army side when we're both in Austin and just at AL event. Can you give just one example what some of the users were saying? Well, we're kind of looking for an edge X, and they go, well, you can really do that.
Yeah, so a lot of what they were talking about was trapped data. So being able to connect at site remote and have it sent back in almost immediately real time, right? So real-time data processing, reporting distributed from the edge back to the hub to inform decision-making, and also talking just a lot about easing the warfighter's burden, right? So reducing cognitive load, making sure that they have access to communications and connectivity, even at the far edge. And then also, expeditionary, that came up a couple times. Dealing with how do we do forward operating logistics? How do we make sure that everything's aligned, from the comm side and also supply chain at the basic level? So very interesting conversations last night.
And we get that common across it. So she's been with me at Luke Air Force Base where they have problems of tracking equipment, as an example. We were in Tampa and got all kinds of good use cases of could you do this? Could you do this from the boat to the shore to the forest type things? And it is, as she said, it is really about trapped data. And so what you will find, what we pride ourselves on IoT AI is unlocking the trapped data, enabling the communication, collaboration, and constrained environments, and really getting rid of the hype of AI ML and all the promises that they have, say 2030, 2040. And what I would tell you this is our biggest problem is we're ahead of requirements. And so a lot of times, because we've created such a fused system at such a low swap, we've even had members of the service that we're not quite sure what to do with you because you're beyond requirements. That's where we need your help. We need sponsors. We need real environments. Put us in the exercises. Take us out of the shore, on shore, take us offshore, put us in the air, and let us prove it to you, because that's where we have done our best activities, is when we get with the users and talk about what we can do to unlock their pain points that they're very frustrated with, that a lot of times they're getting from the S&T teams, or they're actually getting from the requirements that are years behind. So thank you again for your time, and I'm glad Amanda brought that up, because that trap data is a key part of what we do.
Thank you both. Excellent presentation. Thank you
Have a
all.
good
We
one.
will go to our 5-minute break and resume at 2:45. Thanks.
Thank you again.